Hello, good morning, welcome back. Today we're going to be doing another algorithm challenge, okay? Now this one requires us to go through and do a few things. We've done all this stuff before, so I'm just going to go back and review what we need to know, and then I'm going to start working on some of the logic itself. Specifically, we're doing the symmetric difference challenge. So what I'm going to do is I'm going to share my screen, and then I will show you a little bit about what we need to know. So let's start off here with the challenge itself, and it's called Symmetric Difference. And we're looking at this specific challenge here in freeCodeCamp. Let's take a look at the symmetric difference. We're talking about a mathematics. It's a disjunctive noun of two sets of, it doesn't matter. Look at the Venn diagram. All right, we're looking for two arrays that we're going to be given with values, and we're looking for mutually exclusive values, okay? Not only that, but what I'm looking for is the individual value itself that's mutually exclusive, such that, if this makes a little more sense, we have an array here with 1, 2, 3. We have an array with 5, 2, 1, 4. 1, all right, is in both arrays, so it's not unique. 2 is in both arrays, so it's not unique. 3 is only in the first array, so keep that. 4 is only in one array, so we want that. And 5 is only in one array, so we keep that. All right, and that's what we're looking for. What else do we have here? Here we have 3 arrays. When we have 3 arrays, we're going to be doing the same thing. All right, except what I'm going to be doing is down here now. Take a look at this picture. This doesn't make sense at first. Okay, at first this doesn't make sense. The reason being that it would seem this area in the center here, all right, is actually contained in all 3 values. But here they give us a link to a video about symmetric difference that you can click on. It's a YouTube video. It's pretty good. And essentially what happens is if we start here and we cancel out all of these values here in the center, all right, with these 2 arrays, then we get rid of all of these values that would overlap first. And then when we add in this 3rd array, all right, these values in the middle no longer exist, right? So we do this one, then we add this one, and then we add that one. And you can see how sequentially they would cancel out these values, and then in which case those values would not exist. Therefore, this center portion of values would actually count here. So what would that look like with 3 arrays? So the first thing we would do is we would look at these first 2, and you could see that 1 here, we only need to return that 1 once, okay? And then we look at the number 2. Number 2 shows up in multiple arrays, so we don't want that, all right? Specifically, we're only really going to look at this one right here. So we're going to have a number 1, and then look at 5. Oh, 5, they both cancel, so we don't need it. And then we're going to take a look at 3, and then we would have 3, 1 and 3. Then we would be adding in the second array, and the 3 that we would have, all right, would actually be in this array as well, so it's going to get canceled out. 4, all right, 4 is unique so far, so we would add in 4. And then 5, 5 was already canceled out before, so it's not in our final array. So now we add it once to our final array, and we should get 1, 4, 5. So what we need to do is we need to accumulate our final array by adding one array, then adding the other array, and then checking if the values already exist. So that means we have to do it sequentially, okay? Which we can do when we add everything together. And then we can use, all right, a reduce method, all right? And in order to reduce that, which is what they give us, right? Scroll up here. They give us this reduce method here to use because the reduce method actually has an accumulator. Here we go. So reduce method applies a function against an accumulator and each value of the array from left to right to reduce into its single value. So essentially what that means is it's going to be adding those values from left to right. And if we're applying a function to those values, all right, if we're applying a function to those values and we're going across different arrays, we can compare one array to the second array and then have that accumulated value, then add the 3rd array and add that to the accumulated value, making sure we cancel out any repeats. And before we do that, of course, we have to make sure we go ahead and we take care of any duplicates in the individual arrays themselves. All right. So we're going to be using reduce here. And when we use reduce, just so you know, um, we're just going to be doing a pretty basic thing here. Let me see. I've already started off here explaining kind of what we're going to be doing. And when we get to reduce, we can actually call a function on that, right? So we have to do this sequentially. So I'm actually going to be taking these args and I'm going to be reducing them by helper functions. Okay, so I'm going to write these helper functions first, and then I'm going to use the reduce to do things sequentially. So that way I can just keep adding as many arrays as I want and getting the correct symmetric difference. And that's going to be key, is doing that in order to get the correct values. So the first thing that I'm going to be doing is going through and looking at a filter method. So that way I can filter out any values that are duplicated within the individual arrays. So how are we going to go ahead and do that? Well, for this right here, we're going to be going through and let's go over here. I'll show you what else we need to do. Let's go to slice. What I've done is array.prototype.slice.call. That's what this is. And what we're doing here, we've done this before. We have args. Args is an array-like object, but it's not an actual array. We can only call length on it, and I think something else. It says it somewhere. I can't remember it offhand, but it has fewer properties. So by applying this argument here to it, now we have an actual array, and it's actually should be a two-dimensional array. We have an array of arrays, so now we can work with it as we like. So that's where this comes in here, which is why I actually have that next in my things to click on. Which is here. And then also we're going to be using slice as we would normally use slice as well, where we have this method returns a shadow copy of a portion of an array into a new array object. All right, selected from beginning to end, and if the end is not included, it'll just go from the beginning of the slice all the way out. And remember, these arrays are a zero-based index, all right, which is going to be important. The other thing that we're going to be doing is, let's go back here to where we're looking at these individual array value filter here. In order to do that, I'm going to use a for each. And for each, all right, is a method that executes a provided function once for every array element. Essentially, for each is going to apply a function to each individual value, right? And all I have to do with that, since it's an individual array, is just check for, all right, the index of that value, all right? So that's all I'm going to be doing. Is remember, the index of is what I'm going to be using. And index of gives you the index number on that zero-based index, or a -1 if it cannot find that index. All right, so that's how we're going to be using it, is essentially taking a value, finding the index of it. All right, and if it has an index number, then we know it exists. If we get a -1, we know it doesn't exist. All right. So what I'm going to be doing is let's get started here and try to make sense of everything. So now we've gone through for each, slice, reduce, symmetric difference. Good. I tried to set everything up ahead of time so this video isn't like an hour long trying to explain everything. So if it's too brief, you can always ask me questions and I can clarify some stuff. I just don't want to make this ridiculously long, this video that is. So let's start with our first helper function, and I'm just declaring this function. I'm not actually using it. All right. So in our first helper function, I'm just going to be calling this function duplicates. So this is an individual array where I'm going to be taking away any duplicates in the individual arrays themselves. And notice that we're going to be doing this first to all of the arrays before we go ahead and reduce each individual array and into one. So this is going to happen to every single array first to get rid of all of their individual duplicates. So we're just going to call a function. All right, and in that function, I'll just call it duplicate, all right, or dupe. That sounds fine. And I'm going to be taking in an array. All right, so all I'm looking for is an array. Remember, this right here, it doesn't matter what this actually says. This is just for my own sensibilities, knowing that I'm going to be taking in an array. All right, that's not as critical as what you call that argument. All right, and in here, I'm going to be using for each. So I'm just going to be taking in that argument and doing something for each element of that array. Now, the thing is, I need an array to push values to. So I'm going to check if there's a duplicate. If there's not a duplicate, then I'm going to push that value up to a new array. So I need to create a new array. All right. And this new array is what I'm going to push values that I want to keep. Okay. So now I need to run a test. Right? Is there more than one? If it passes that test, push that. All right, so I told you before we're going to be using this for each, and we're going to be taking in an array. Now I have an argument that I know is an array, and I just called it ARR for array. All right, so, and I know that told you I'm already going to use a for each method. So array.forEach, and for each, remember, is going to apply a function, each one of those, and that function is going to take in the individual value. So, I mean, you can just UV for value, whatever you want. You can say value if you want, or you can say number, whatever makes more sense to you. So when you come back to this, you can read it. I'll say value because I think that it tends to work pretty well. So value, and what'd you do? There we go. I hitting control instead of shift there. I was wondering what was going on. It was confusing me. So essentially, all I'm going to do is individually push values into a new array. Okay? Every single value I want to push, except if there's already that value in my new array. So it's pretty simple. So all I'm going to do is just say if, all right, new array, if new array, all right, if I can take the index of the value. All right, so the index of the value. So this is what I'm looking for is I'm checking this new array, which currently is blank. That's going to start off with. It's going to be looking for the index of each individual thing for my initial array. All right, and if that exists, if there's an index of that value in my new array, that means that the value already exists there. So I don't want it. All right, what that means is that if that value is a -1, however, so less than 0, or you could say equals -1, either one of these work. So if I get a -1, where is my index of? -1 if not present, okay? If the index is not present, which means the value is not present, you get a -1. All right, so if it's, I'll just say less than 0, or if it does equal -1, all right, I want to do something. And what do I want to do? If it can't find the index of that value, all I want to do is new array dot push the value. And I'm sorry, I'm rushing here a little bit, trying to get it all in here. All right, one more time. So we have an array coming in. Then I also have a new array. I'm going to do a for each method on every element of this array. If the index of that individual value does not exist, all right, or if it so means it comes up -1, push it to that array. Then check the next value. If that value is the same as a previous value, you will get an index number that is greater than 0, right? Well, it's going to be 0 or greater because the first individual value is going to be 0, right? Because the first value on an array, it's a 0-based index. If it's 0 or greater, that means we have an index number, which means it already exists in the new array. Therefore, we don't want to push that value. That's why we don't need an else. We can just say if. All right. So we're all good. What we have to do to end this helper function is we have to know where to return our new array. So the output of this function, this dupe function, is going to be a new array with no duplicates. So this right here is the if. This right here, you can see it just highlights there, is the for each. So after the for each is done, I want to return the new array. Right? So there's one helper function done. Next, another helper function. So our next helper function, what do I want to do? I want to create a new function. So let's just name this here. Function. All right. And what we want to do is now that we have, after we get all of our arrays with no repeating values, I want to concatenate those arrays and then remove any unique values. So I could, again, go ahead and try to do this and use some recursion. But if I do it that way, I could run into some values, some problems with this whole thing right here. Remember where it has to be sequential? I couldn't get that to work. Maybe because when I did it, when I tried to use the recursion, it was just canceling. It seemed to be canceling out this middle portion here. And maybe I just set it up wrong when I did it. So this is what I found through some research. It actually works. So this is what I'm going to show you. So what I want to do is I'm going to have a function, and then I'm just going to call this final. All right. And final itself. All right. What do I want this to do? So final, or final, I'll call it final array. All right. So my final array, I want to call this, and I want to take in two arrays. I'll just call it ARR1 and ARR2. So I'm expecting two arrays. So it's going to deal with two arrays at a time. If I have multiple arrays, all right, I'm going to be using the reduce method here. And remember, reduce is going to be taking in an accumulator and a value, and it's going to keep doing this over and over to the accumulator. All right, so this array1 is going to be the accumulator. All right, so let's keep that in mind. All right, and we're going to do this down here. It's going to be very similar to this. All right, in this case, we're only going to be doing this. So we're going to be calling this over and over again, and this array1 is going to end up being our accumulator later on. But we don't have to really worry about that right now. All we have to know is that we're going to come in here, and it looks like we need to check the index of before and check the index of after the value. So since we already have two arrays, we don't have an individual array, we could try to concatenate it and do it like this up here using some recursion. But instead, I found this, which works really good. So I'm going to make another new array. And now this new array, remember the scope?
Nathan Torres, please report to the main office. And Nathan Torres, please report to the main office.
All right, sorry about that. Working in a school here, that goes off every now and then. Anyway, the scope of this variable new array here, all right, is only valid inside of this function. So I could actually just go to var and call another new array here if I want. All right, or I can say ARR3. Either way, that would work. All right, so I'll just call it ARR3. And what this is going to equal is I'm just going to concatenate both arrays. All right, equals ARR1 concat ARR2. So now I have a third array, which is just all this stuff stuck together. All right. And what am I going to do? All I'm going to do is something pretty simple. Like I said, I could actually try it this way, but it didn't work for me. Maybe because I was trying to use recursion. I could probably use the same logic, but Like I said, I found this, which works pretty good too. I like the way this works, where you're just going to return this new array here, ARR3. When I do this, I'm going to first use a filter method. All right, filter function. And the reason I really like this is for this reason. All right, so let's go up here and let's take a look at something pretty cool. And that is inside of the filter function. So I'm going to go over here and find filter. And this is the first time that I had to use filter in this way. And it's really cool because if you look at the parameters for filter, not only do you have a function, which is the callback. If you notice, I already have the filter function. Okay, that's my callback. Hey, where'd you go, filter? There's filter. All right. But also, I have arguments. And now what arguments? I can have up to 3 arguments in this filter. All right. So how do I do this? Well, what's cool is the arguments I could take in is the element, okay? Whereas the element itself is the individual value. Then the filter function here, or this filter prototype or this filter property, also will know the index number of that element. And I can make sure that the filter function is self-aware of the individual array. So I could use things like array.length, and it'll know that I'm talking about the entire array that I am filtering. It's pretty cool. So what I'm going to do is I'm going to use all 3 of these parameters, okay? I'm going to use all 3 of these arguments, and I'm just going to call them just like they are. They're 1, 2, and 3. They need to be in this order: element, index, then array. So let's try this out because this is really neat. So element, all right? So the element is the value, the index is the index number, and the array, all right, is the actual array itself. And those are all of the optional arguments, or the parameters that we have. It's pretty cool that we can do this. All right, so I'm going to come down here, make sure I finish that sentence with a semicolon. So now I'm inside of this filter function. How am I going to do this? All right, let's start off by saying that I'm going to check the index of the value before. So if I start off in an array, let's just say that this was my finished array here. If I get to 1, I want to slice before the 1 and see if there are any 1s, all right, by using the index of. Currently, if I go to this one, there are no 1s before it, right? Then what I want to do is check afterwards, right? And say, all right, I want to slice 1 ahead. So if this is index 0, I want to slice at index 1. So I'll slice right here and check all of these values for the index of. Notice that I have an index of right here from these new values, which means I'm going to get a value that is not -1. All right. Therefore, what I'm going to do is, since that value is not unique, okay, that value is not unique, they're going to cancel each other out, and I'm not going to return it. All right. Let me say that again. We are looking at this brand new array that's made from 2 arrays. We're pretending that this array was made from 2 arrays. And just like up here, with these 2 arrays, if we were to combine them, you notice that 1 and 1 are not mutually exclusive, so we do not include them in the final array. Okay? We do not include them in the final array. We don't just, we can't just use this like a recursion up here, because it would actually keep this number 1. So what we need to do is get rid of both of the number 1s. Why? Because they're not mutually exclusive. All right. So I know this is why this works, and I couldn't get the recursion to work. But if you do know how to do this with just one function, that'd be really cool. So if you could let me know or send me a message on how you did that, I'd like to see that in a better, in a cleaner way than this. But anyway, so let's do that. So all we have to do is come in here, and we're going to have an if statement. So if this and that, then just return our value. All right. So how do we say this? What's cool is, remember, we have element, index, and array we can use. So we can just take a look at if the array dot slice. Now we're going to be slicing. Remember, we want to slice right at that index number. All right. For if we slice right at that index number itself, so if I slice at 0, that's going to check before. If I slice at index of +1, it's going to slice right after it, and then we can check after. All right. And remember, slice takes in a value and slices from where it starts all the way to the end. So let's do the index. So slice. And let's use slice to go from 0 and go all the way up to the index. So if we go from 0 all the way up to the index, in this case, from the 0th position to the index, in this case, it's 0. So we're checking nothing from 0 to 0. If that has an index number, all right, which means everything before it. So if we look at this one here, if we use the example of the second one, we'd be slicing it right here, and then going from 0, and it's going to be including this 1, and the index of that is going to be 0. All right, so it has a value. Since it has a value, all right, we don't want to return it. So I only want to return things that show up with the index of value, right? So let's take a look at this. So now we have the value itself included, and then I'm going to take the index of that, index of element. So again, the index of this element. And I only want to return it if it is exactly equal to -1. And that's going to return everything before. All right, so if I can't find that index value before it, all right, which means it's a unique value, but don't forget I have to check after. Oops. How do I check the after values? Again, it's just going to be array, which is the array itself. I'm going to slice, not slice, but slice. And what are my after values? Well, my after values are just going to be the index. Remember, if I use the index, it's just going to slice right before it to include it. But I want to slice right after that value. And slice goes, if we don't give it 2 parameters like this, it's going to go from wherever I tell it to go to the end. So I just want the index of 1. All right, and that's going to slice directly after. So if, let's say our final array was this 2, if I said slice index 1, it's going to slice right here. If I say index +1, it's going to slice right there, right after. Since I don't give it a second argument, it's going to include everything to the end of that array, which is what I want. So this is my after. So this is my before, and this is my after. So index, right? And then I need to take the index of that, and index of, and again, you're using the same element. Again, that's just the actual value of it itself. And that also needs to be equal, exactly equal, or strictly equal to -1. So if we get none of the same values before it and none of the same values after it, so it's only the only one in the array, the only value of that inside of the array only, all right? Only if those 2 things are true. So it's a completely unique value, then return element. Okay. That was a lot, right? So hopefully you could follow me there. Like I said, I'm trying to rush through as fast as I can with this because I know this tends to be a longer explanation. Okay. So now what we have here is we've got rid of all of the duplicate values, and now one by one, we only are keeping values that are unique, that only show up once. Okay? So you see how these 2 act differently? All right, so they do act differently. Now, that's all good and fun, But now I actually have to put these into my final return statement here using a reduce method. So now I can reduce whatever this args is. Remember, I started off by making sure that my arguments are an actual array, not just an array-like object. And I'm going to do this by just returning and then reducing. Reduce, not reducing. Reduce and reduce. Remember, it takes in your callback or your function. All right, and your function always has an accumulator and then what you're going to be accumulating into it. And remember, you can take as many things in as you want, but just remember the first thing is going to be your accumulator, which is why this symmetric difference works. We're not just looking for what's mutually exclusive with all of them, but the symmetric difference does this first and then overlaps that third. So we have to be able to keep this inside area here, which is why we use this reduce function to do it one at a time. All right, so reducing the function here, and I know I have an extra one of these. All right, there we go. And how are we going to reduce this? So the first thing I'm going to do is take my accumulator array, and I'm going to set that equal to, make sure that I have no duplicates, okay? So I'm just going to call that dup A, right? And that's going to get rid of the repeating values in the A array, in the first array. And then I want to do the same thing separately to the second array that I'm going to be adding to this, which is all I'm doing here. So first I'm going to get rid of anything in my accumulator array that's duplicate. Then I'm going to get rid of any duplicates in my array that I'm going to be adding to this using this final array function. And then my final array function is going to be taking in 2 arrays, right? So I can take my final array function. My final array function is going to take A and B. And remember, that is going to look for values that if there is 2 values, right? If the value is duplicated at all right, which means it was originally in both arrays, get rid of that value entirely, which is what this does. All right, this final array AB, final array. Remember, A and B are going to be 2 separate arrays. All right, and then that should work, and I should just be able to return A. All right, whew. That was a lot. So let's see if this works. To infinity and beyond. All righty, it worked. All right, and then we can move on. So again, hopefully this was helpful to you all. You can take one more quick look at this. If you have any questions, you can contact me or just ask me. But here's the code itself. Remember, I have a helper function that I split out so that way my logic makes more sense. Alrighty, so hopefully this was helpful, and then I will see you all next time.